Hello everyone, good morning. Could you please open your textbook, page 56, Unit 1, textbook again, Lesson 4, Solid Liquids and Gases. Please open page 56 in the textbook. Alright, on page 56, you will see the explanation, state of matter. Alright, state is another physical property of matter. Solid, liquid, and gases are common forms that matter can take. Each state has specific characteristic. We already spoke about it in the PowerPoint and in the activity as well. But now this is the book explanation. So, a solid has a definite shape. I encourage you all to pick up a highlighter and highlight with me in the textbook what I'm highlighting right now. It is important. So, a solid has definite shape, all right? Solid has a definite shape, meaning the shape of the solid will not change. Look at this stack of books, all right? If I keep this stack of books for 1 day, or 2 days, or 3 days, or 5 days, or 1 week, or 1 month, or even 1 year, the shape of these books or stack of books will not change. All right, this small book will not suddenly increase in size or decrease in size, or somehow the particles of this book will disappear. No, so it has a definite shape. A definite shape meaning the shape will not change and takes up a definite amount of space. Again, observe the picture of this stack of book. Takes a definite amount of space. It's occupying this area, all right? It's occupying this area and it will not move and occupy another area at the same time. So it's occupy the same amount of space, meaning having the same volume, all right? So, and highlight with me also, and takes up definite amount of space. A solid stay in its definite shape with a definite volume unless it is changed by an outside force. Highlight for me the word unless, all right? Changed by an outside force. What does this mean? Go to the picture again. The picture is inside your textbook, by the way. It's the same picture. If I do not pick any of these books, or I do not destroy any of these books, or do not touch it at all, it will stay the same, right? What if I start removing the books here, or moving it around, changing the order of these books? The shape will change, right? The stack of books shape. I'm talking about the stack of books shape, not the book, each one individually. So the outside force will be here, me actually moving the books, or me actually doing something to the books, all right? So this is the outside force. The particles in a solid are tightly packed together and vibrate. Tightly highlights the word tightly packed and highlight vibrate. Vibrate mean it does not actually move around, all right? It does not move. It's only vibrate and you cannot see it with your naked eye, all right? Only the tiny particles under the microscope, super microscope, it will vibrate, all right? In staying in the same place, okay? Now liquid. A liquid has definite volume, all right? Definite volume mean, look at this picture. The liquid from inside this bottle is pouring to the glass. The amount of, I think this is 7-Up, it's not water. The amount of 7-Up inside the glass will be the same inside the bottle. So the volume will not change. The amount of space that this liquid occupy will not change, all right? What will change is the shape, how it look like inside the container. Highlight does not have definite shape. It can be poured from one container to another easily. The liquid fills the shape it is poured into from the bottom up, right? So when you put from the bottom up, they mean when you pour this 7-Up inside the glass, it will start filling it from down to up, all right, until it reach the top of the glass. The particles in a liquid are usually less tightly packed, highlight, less tightly packed than solid, all right, this is important, and can move, and it can move. Solid does not move, vibrate, all right. One example, what, excuse me, one example in which this is not true is water, all right? So water is actually more dense than ice. Ice is solid, right? Ice is solid. Water is liquid. Technically, solid should be more dense, but in water case, the ice will be less dense than water, which is why ice floats in the glass. When you put ice now inside this 7-Up, you'll see the ice up, not down, not sinking. Have you ever asked yourself this question? Why the ice is not sinking? Because the ice is less dense than the water. The density of the ice is less. Okay, now gases. Gases have no definite shape or volume. Have a look at this picture. He is pushing air inside the basket ball, right? So the air will take the shape of the ball. If he was pushing the air inside a balloon, the air will take the shape of the balloon, whatever the shape is. So if I'm pushing the same amount of air here in the basketball, it will take the shape of the basketball. Of a football, it will take the shape of the football. All right. The particles in gas are much the particles in gas are much farther apart than particles in solid and liquids. They're scattered around, right? Remember the marbles in the PowerPoint, they're scattered around. They can move around each other very easily. Gases spread out and completely fill a closed container. If you make the container bigger, the same amount of gas will expand to fill it, all right? So meaning, if I want to put the same amount of gas here in a bigger bowl, for example, all right, bigger bowl than this, the same amount of gas will fill the other bowl completely as well, all right, because they are scattered around, the particle of the gas scattered around. Thank you so much for watching. Have a nice day, everybody.